And so we're now on to our next lesson, which is all about comparing fractions. When we compare fractions, or in fact when we compare anything, what we're actually doing is we're deciding, is something bigger than something else? Is something smaller than something else? Or is something equivalent to something else? So those are the three options that we're going to be looking at. Now, it's always a good idea to start off with an example where you would know the answer even without looking at it. So 3/4, you will know that 3/4 is going to be bigger than 1/2. So let's have a look. And first of all, let's use the bar model to compare these two fractions. So we'll have 3/4 at the top and then 1/2 at the bottom. 3/4. 1/2. Okay, and remember, all we need to do is come up with a statement that says something is either bigger, smaller, or equivalent to. Now, 3/4, in order to show on the bar model 3/4, obviously we need quarters, and we need to shade in 3 of them. There we go. Halves, for the half, we need to show halves. So we've got 1/2 there and 1/2 there, and what we need to do is shade in one of those halves. Right, and then we need to compare this model with this this diagram with this diagram, and we can clearly see that 3/4 is more than 1/2. So therefore, we put the greater than symbol in. Now, just in case you've forgotten which way round it goes, imagine if you put a ball in this part of the symbol. There's a very, very small ball, and you put a ball in this part of the symbol, okay, then you can very, very easily see that this ball is bigger than this ball, and it works, it works the other way around. So please don't get mixed up for which way round it goes. So therefore 3/4 is bigger than 1/2. Okay, moving on then, in the second example, we've got an example here, 3/4 and 3/5. Now, you'll quite often see a question like this, because what they're trying to do is they're trying to trick you, and they're trying to make you think, well, 3 and 3, so therefore this must be the same, but it's not, as I will show you in a moment. So first of all, let's use the bar method. 3/4, so we've got a rectangle with quarters, and we shade in 3 of them. And then we want to compare that with 3/5. Now, the thing about 3/5 is, or the thing about this rectangle, it doesn't matter. It does matter that the rectangle has got to be exactly the same size as the first rectangle. Okay, so therefore the width of the rectangles has got to be the same, because otherwise you can't compare. And then you've got to divide this bottom rectangle into fifths. Okay, now because we want to represent 3/5, we shade in 1, 2, 3 of these, and then I think you can see fairly clearly that 3/4 is more than 3/5. Okay, so 3/4 more than 3/5. Okay, now in the next example, we've got 6/7 and 6/8. Now, sometimes the examples I give you might be difficult to compare using bar models, but I'm going to show you how you can use part of a bar model to help you. Now, 6/8 that shouldn't be too difficult, because to divide a rectangle into eighths, you know that first of all you divide it into half, and then each rectangle that's left you divide in half, and each of those rectangles that's left you divide in half as well. like this. And then just to check, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we want to represent 6/8 here. And so therefore that's each one of those 1, 2, 3, 4, 5, 6. Okay, now to represent 6/7, that's going to be difficult, but let's at least start. So therefore draw the rectangle, come down, go along, and back up again. Now, to split that rectangle into sevenths is going to be really very, very difficult, okay? But what you've got to do is just think very, very clearly for a moment. If we're dividing that into sevenths, into 7 different pieces, then each piece is going to be bigger than each of these pieces, okay? Because here we're dividing it into 8, and here we're dividing up into 7, and because it's a smaller number, each piece will be bigger, only slightly bigger. So therefore, for example, the first piece will be that big. So if we shade that one in, then we can see that this piece is bigger than this piece. Now, because we're looking at 6/8 and 6/7, when we come to do our shading, 2, 3, 4, 5, 6, the one at the end is going to be not shaded. But when we come to do the shading, we're going to see that that 6/7 is going to be bigger. Okay? So let's just go back a couple of minutes to explain how we know. The reason we know is because when we divide something into 7, each piece is going to be bigger than if we divide it up into 8. And if you don't believe me, then have a practice. Divide something into 4 and then divide it into 8 and compare. When you divide it into 4, each piece is bigger than if you divide it into 8. Okay, so that shows you that when you divide it into a smaller number, the pieces are bigger. Okay, right, so that means that as we've shown from here, because the numerator is the same, 6 there and 6 there, what we've got is we've got 6 smaller pieces at the top and 6 bigger pieces at the bottom. So therefore 6/7 is going to be bigger. So 6/7 is like that. Okay, that's another example. Okay, here's another example which starts off being really, really awkward, and you think, oh my goodness, how are we going to do this? But if you look at it carefully, you can find out very, very quickly. Remember, when we're comparing, we don't have to say how much bigger, we don't have to say how much smaller, all we have to do is say bigger or smaller. Now, 6/13. Now, if you want, you could start off with a rectangle and you could divide it up into 13, if that's right, and then you could shade in 6, 1, 2, 3, 4, 5, 6, and then you could have so 6/13 is this, okay, and then I'm going to draw a line here so we don't get mixed up. 20/13. Now already some of you might be thinking, well, 20/13, that's weird. So get the same size of rectangle, divide it up into 13, and oh, hang on a minute, we've got to shade in all of them to represent this, and we've got to shade in another 1, 2, 3, 4, 5, 6, 7, because 20/13 is more than 1. It's actually 1 and 7 13ths. So if I just get rid of this, in fact, let's get rid of all of this, because all of this you don't really need. All you need to be able to recognise is that 6/13 is less than 1, less than 1, and 20/13 is more than 1. So therefore, you can very quickly say more than like that. Okay, 6/13 is less than 20/13. Okay, now another example of a question they might ask you is, they might give you this. So 8/10 is less than box. Okay, and what they might say is, complete this statement with a fraction with the same denominator or with a fraction with the same numerator. Okay, so let's take the first example. Complete this statement with a fraction with the same denominator. Now denominator means the number at the bottom, so therefore we've got to put 10 in there. Now this is fairly straightforward. 8/10 is less than, well, this is simply, all you've got to do is think of a number which is greater than 8. So therefore the obvious answer would be 9. So 8/10 is less than, sorry, let me start that again. 8/10 is less than 9/10. Okay, and again, if you want to check, you do a bar model with and split it into 10 squares, and at the top you shade in 8 of them. 1, 2, 3, 4, 5, 6, 7, 8, and at the bottom you shade in 9 of them, something like that, and then you'll be able to see that 8 is less than 9. Okay. Okay. The next part of the question is a different way of wording the question. Is, it could say 8/10 is less than 8 what? Okay, 8/10 is less than 8 what? So now it's probably a good idea to do a decent rectangle. 8/10, so, and 5, there we go, and 5, 2, 3, 4. So 8/10, you've got that, 2, 3, 4, 5, 6, 7, 8. Right. And then, because we're comparing, you've got to have the rectangle at the bottom's got to be the same size. Always draw them the same size. And then you've got to think, right, so 8/10 is less than. So we've got to have something that's going to take up more space. Okay, so... Okay, so a way of doing this is to think a little bit earlier on in the lesson when we talked about the numbers at the bottom. And if we divide this rectangle into 9, then each section is going to be bigger than if we divide it into 10. And if each section is going to be bigger, then 8 big sections is going to be bigger than 8 smaller sections. So therefore, if that was a 9, then that would work out perfectly. Okay, so just to sum up then, when you are comparing fractions, remember all you've got to do is say, is a fraction bigger than another one? Is it smaller than another one? Or even, is it equivalent to another one? Try to use a bar model. Those are good for small fractions, small numbers. Try to see whether fractions are equivalent, and try to simplify fractions. And we've dealt with all of these in either this lesson or previous lessons this week. Okay, go back to the website and follow the instructions for the next part of the lesson.